Okay, I'm getting ready to bore our Lincoln Continental 1948 292 V12 engine, and we got our pistons from Eggy, and I mic'd them. We're going 60 over, and I mic'd the pistons, and they are exactly 2 thousandths undersize from the nominal bore size. Standard bore on a 292 Lincoln Continental V12 is 2-inch 875. Okay, so 2 7/8. So if we add 60 thousandths to that, that's going to be 2-inch 935 as a nominal size. So I read Eggy's instructions, which I have many times in other jobs, which you always should do, and they basically reiterate where they want you to measure the piston, and they basically say the clearance is set if you bore to the nominal size. Which, yes, they're exactly right, but you always should check. I mic'd every single piston. They mic all the same because you never know what happens, shipping, whatever. You know, yes, they say there's 60 thousandths over, but, you know, who knows? So it's up to the machinist to make sure everything's right because it's our baby if something's wrong. So, but anyway, I've got all these mic'd up. They have a specified clearance, okay, that they want of 2.5 thousandths, okay? So we like to go 1 over that. But they also recommend that you can go half over or 1 under. So we're going to finish this at 2-inch 935.5. So that's going to be my finish bore size on this engine. Walk over here to the boring bar. Since this engine is a 75-degree V8, or excuse me, V12, we can't use our Rottler bar because our Rottler bar can either do straight up and down, 90 degree or 60 degree. So even though that's a good bar, we can't use it in this application. So we had to dig out of the shed the old Quickway FN bar that we've had for 30 years. This is a good old bar. It bores off of the deck surface. So I've got it on the stand here, and being as I'm off the deck surface, the angle of the block of the V doesn't matter. But since the Rottler bar bores off of the oil pan rail, it's mission critical that you either got those 3 choices, 60, 90, or straight up, or 180, I guess. But anyway, I've got the boring bar set up. What I've done is I've got the mic right here, all right, for this old Quickway FN. I've got it set to 2-inch 934, okay? Right there is what I got it set to. So I'm going to leave 1.5 for honing. Don't want to leave too much because that's a lot of work, but you want to leave too little because you want to give a nice crosshatch pattern. So we're going to go ahead and fire up our old school bar here. Flip the toggle switch, turns it on. I've already ran it down. So we'll go ahead and engage the spinner. All right, and then I'm going to go ahead and flip this guy. That'll pop in. There she goes. Okay, that handle starts turning. And we're cutting. So once we're done cutting, we're going to measure and see where we're at. Make sure that our bar is cutting what it says it's cutting at. So I'll be back after that. Okay, we're finished with the first hole. Come out pretty nice. Let's check the bore, see what our boring bar is doing. See, it's cutting about 5 thousandths under, so each big line is 5 thousandths, so let's do, make sure it's boring not out of round. Yep. So see, she's cutting about 5 under. So what I'm going to do, since I set the bar up to cut 934, I'm going to add 4 thousandths to that. So I'm going to set the bar to cut 938, even though it's cutting under. That way it saves, because this one here, I've got to hone 5 thousandths out. So that's a lot of work. So, okay. So we'll know what to do on the next one. All right, I've got all 12 holes bored. I reset my bar to cut 938, even though it's cut 934. And I'm looking for about half to 1 under, which is what I have. That's perfect. So, but we discovered something here as I was doing this. The driver's side bank come out great, but one cylinder on the passenger side bank, I don't know if the previous machine job, the boring bar that they, whoever they used was bad, but look at this. It missed. I don't know, this is gonna be hard to tell with this camera, but there you go. See down in there, way down there, that's about 10 thousandths out. So of course we measured it. You know, this thing was previously bored. This thing doesn't have hardly any miles on it since it was done last, wherever it was done. But it had absolutely no oil pressure. It was noisy. It ran like crap. The valves weren't seating. It was just a very, very, very poor workmanship on this engine. And it's too bad because this is such a rare engine. It's not like you can just go buy one of these. But you can see down there at the bottom of the bore where I got the light, it didn't hit. So I'm gonna have to probably sleeve this hole. The rest of them came out great. But to have that kind of issue down at the bottom of the hole like that, that sucks. And that's where the piston lives. So, you know, that could knock or anything, you know, piston slap. So we're gonna have to fix that. So I'm probably gonna have to sleeve this hole. We're already 60 over. So maybe we can get a 3/32 sleeve and sleeve her up. But I'm gonna see what we can do, but that's not cool. Other than that, we're in good shape. But hey, that's what happens when you work on a lot of old stuff. Things happen. Okay, I want to check all the workmanship on this engine. So I set up our AG 300 gauge here on our Sun and Rod machine to check the big ends of the rods. I noticed on some of the rods, the machining, there was no machining in certain areas. So that's a red flag. So this one I just checked. I didn't even finish checking the rest of them, but this one here, basically how this works. All right. 2-inch 422 thousandths to 422.5 is the spec. So I set my gauge up. 0 represents 422. It's not bad. But watch as I rotate this thing like 90 degrees. Look at that. It's a thousandths wide. I mean, the green is clearance. So it's a thousandths, almost a thousandths and a half bigger out of round. See? Wow. So we're gonna have to go through all these rods probably. You can see that they were machined, but I don't know what's going on. This thing had no oil pressure, you know. That's why we're checking all this stuff. So gotta do what we gotta do. All right, so I've resized all the rods. This is just what it looks like when we got done. See, that's perfect. I set it up, the 0 represents 422. It's 422 to 422.5. So, and you see where I put that thing, that's perfect. So, we got her done. Good enough. Okay, we're getting ready to put our sleeve in our V12 here. Getting ready to do the last 15 thousandths or so cut. I'm just checking the boring bar, making sure that we're close. So now that we've shortened up the cuts, we're getting bar's cutting about 1 under. I just set it to 3-inch. Oh, wherever it's at here. I set the mic to 3-inch 44, and when I mic'd it, it come out to 3-inch 43. So that's good. So we're gonna set the sleeves mics. The sleeve mic'd 3-inch 65.5. So I'm gonna set my bore up to 3-inch 64, and that'll give us 1.5 press fit. So we'll see what happens. Okay, we're going with our final pass. Bar when on these heavy cuts is cutting about 3 to 4 under. So I set my my mic up to, or the boring setting tool, bore cutter setting tool, to 3-inch 938, and we're gonna go to town here. Flip the old switch, go down for slow drive, and then engage. Here we go. After the commercial break, we'll see what we did. All right, let's check out our sleeve job here. They come out really, really nice. Looks good. The old quick way does a nice job still. And let's measure it. So we got our dial bore gauge set to our finish size. And we're about 1/1000th undersized, which is perfect. That leaves us 1/1000th to hone. It's less work on me and my back. And it's really good. I'll check, make sure for the taper, or out of round I mean. Yeah, about a half out of round, no big deal. The hone will take that. All right, so there's a crash course on sleeving a 1948 Lincoln V12 292 flathead engine with a Quickway FN boring bar from the early 60s. Okay, we're decking the V12 block. We're getting close to our sleeve. If not, oh yeah, we're already touching it. I'm just taking 3/1000ths off the deck. My zero there, 3.5. Just enough to clean it up before I put the sleeve in. So she's coming. Okay, checking the main bearing clearance here on our V12 project. We had a hard time finding bearings and stuff for this. So the crank was already turned 20 under when we got it, and it mics out good. So we found 20 under bearings for it, because originally this engine had semis. And years ago what happened was you found parts for the maximum undersize. So in other words, I think they were 80/1000ths, and then you ground them with a machine to what you needed. So it had semis on the mains and rods before grounded to 20. Well, I just hooked up our dial bore gauge. I've got our dial bore gauge set to 2" 3/80. That's 20 under on the crank, because the original main bore diameter was 2" 400, 2" 401. So ours mic's 380. So I just did a quick check here, and we are about 2,500. So the spec is 1.5 to 3. So that's pretty good. I'll go along and I'll check the rest of the other 4 and make sure they're okay. So make sure that the parts we're getting are correct and we have no trouble, because remember, this engine had absolutely no oil pressure when it was warm, and I believe it was because of the hydraulic lifter bypass, and we'll get into that later. But we're just going through and checking all this stuff here as we go. Okay, messing with our Lincoln here, getting the valve train all set up. I got all the valves ground. This has 49 to 53 valves in it. It's got a one-piece guide instead of the split guide, which is a good upgrade. That was already done before we got here. So I verified the springs have 51 to 57 psi of pressure at 1 1/8 with our spring tester. So we had to put some shims in to achieve that. That's what that gold thing is. So we have the correct pressure at the closed position to run these hydraulic lifters according to the service manual. So this had solid lifters in it when it came in, so we're going to convert it back to hydraulics. So we sourced some used lifter bodies and rebuilt lifter assemblies. Now these lifter assemblies go into the bodies like such. So there's an oil hole right there in this groove right there that feeds this area right down in there. Okay, that feeds that guy up. The bottom of the lifter, there's a check ball, just like a modern lifter. So oil pressure opens that ball, fills this guy up. It's hard to tell how they compress it, but see how that compresses? Because it's bumped down. But then that will hold solid. We got to verify we've got 30 to 70 thousandths clearance between this and the tip of the valve once we get it in. But oil is fed through, comes up through the block, and then you've got 3 holes here. This is how you know this is a hydraulic cam block. So this here is oil into the lifter galley. So this goes to the oil pressure gauge, this comes out to the filter. So Ford was so concerned about this that the oil filter actually only filters the oil going to the lifter galley, does not filter anything else other than the oil here. So the oil comes out of here, the main galley, loops around, goes right back into this fitting here. So that lifter galley goes right into there. So the oil comes up through there and feeds in. Now, this hole there, that's fuel pump push rod. So this big tube you see in here that's pressed in, that's the actual main oil galley of the engine. So oil comes up through. You see where these little knots are right there. That goes to each main cap. So that lubes, you know, number 2 and number 3 main. And this is obviously number 4 main and number 1. So there's a check valve that goes in here that regulates the lifters to 20 psi. So no matter what goes on with the oil pressure, assuming it's over 20, there's only 20 psi going to the lifters. So then this hole in through there, that dumps out to lube the cam gear, which is out front. So the lifters are fed through a hole. I don't know if I can get in here. Right there. See that hole right there? That's what feeds that lifter pocket and feeds into this groove. So we're gonna go ahead and start putting these things in and checking it. That's what this bar is for. So we can compress the spring. These little retainers here, you basically shove the valve in, and this retainer goes right there. That's what locks it in. I'll show that again. This is flathead Ford stuff. So this valve goes in like that. Then we use this freaking bar, which actually is not the right bar for this engine. This V12 engine is a 75-degree engine. It's not a 90-degree. So this intake opening is much, much narrower. So this bar is actually meant for a flathead V8, which is 90 degrees. So it is an absolute pain because there's hardly any room to get in here to get these clips in. So we're gonna go ahead and get this in, and we'll recheck everything. Okay, I got the valves in, and I'm just checking the preload, lifter preload. Old school service manual says 30 to 60,000. So I checked them all, but this is just a video to show how I ended up doing it. The Ford book says stick a screwdriver under here and get a feeler gauge. Well, as I was putting these things in, you can see they've got, you know, spring loaded, which is good. You know, you want to be into the lifter. So I zero my indicator there, and I'll press this down to the valve. So I got what, 42 thousandths there. Yep, perfect. So I checked all these valves, they're all good. So we can go ahead and put those clips in. Okay, I'm going to demonstrate putting one of the clips to hold the valves in here. This has to be cylinder number 1 intake. There's a groove in the valve guide. Almost. There you go. There's a groove in the block where that sets in. See, there's that groove on the new one. Adjust that over. That's it. I was like, do that 24 times. Pain in the ass, as you can see. Okay, gonna go over the final oiling system here for the hydraulic lifters. This back port here, that big hole, that is where the oil comes up through the main galley. Now, as I said before, the lifters are actually fed through this guy right here, which is filtered oil. But there's a secondary method, probably in case the oil filter plugs up or whatever. So there's this metering valve here that I got all doped up ready to go in. That opens, I'm not sure at what pressure, but that'll open to give a extra oil into the lifter galley, because right there is those little holes are the lifter galleys. Now you can see those were tapped before, and they had all that stuff plugged off, and they had that wide open 1/8 inch pipe hole literally wide open. Well, they had this cheese dick brake line in here, okay? That was originally, when I took the engine apart, that was connecting this to this, okay? Now they had this originally blocked off. You can see there's two little holes there that they had threaded and they had plugs in there. Well, from the research I've done, that's all supposed to be open. That is the oil leaving the lifter galley. Well, that big hole towards the front is to lube the front timing gear. That guy right there, okay? Well, I think what they were trying to do with this brake line is they took that big metering, they took the metering valve out because they say, hey, we don't need oil in that lifter galley at all. But they were getting it from the filter, obviously, before. So this had this wide open hole with this 3/16 brake line going to pour oil into the timing gear. Well, I think that line, it was too damn big. You don't need that much oil in that timing gear. So Ford had this check valve. So this little ball goes down into that seat, and that's supposed to open at 20 psi. So the ball, the spring, and that check, which makes sense. So we'll take leftover oil from the lifters and we'll blow that check valve, and then we'll send it to the timing gear. So that's the way we're going to plumb it. I'm going to prime it up with a primer tank to see what really works and see if we are getting oil everywhere. But we'll do that once we get the rod bearings in. I'm waiting on rod bearings now since we didn't have enough. So this project's going to get tabled again. But I'm going to go ahead and stick these plugs in here and go from there. So like I say, you got a check valve up front that relieves at 20 psi. I'm not sure what this relief valve here, or this metering valve as it's called in the book, opens up just to give some extra oil to the lifters. So interesting, cool old stuff. Okay, I'm going to check the clearance in the rod bearings. So I got my new bearings in there. Like I said, it took 2 sets. These things are hard to get parts for, so I'm going to use our dial bore gauge and check the clearance. So I set the dial bore gauge up to 2" 230, which is what my crank mics. So because it's 20 under, 2" 250 is standard, but since it's 20 under, it's 2" 230. So the service manual calls for 1.5 thousandths to 3 thousandths oil clearance. So I'll stick this in here. High spot. See, we're right there at 1.5. So each little line is 0.5 thousandths. So we're right at the minimum. That's good. I'll go back and check the rest of these. These rods are all weird sizes and everything. That's why I reconditioned all the big ends and that. So I mic'd all the bearing halves. They mic 96 thousandths, even though they're 2 different brands. So I checked all those, but we'll check them all on each rod and make sure all that's good. So since I got the pins all fit, they came out nice. Had to use 2 bushings. But that's a lot of work fitting 12 pins. Oh my God, but we got her done. Okay, what I want to do is I want to pre-lube this engine. I want to check the lifters, make sure everything pumps up. Obviously, before we put it together, make sure everything's right, make sure it holds oil pressure. So I got the valve off. I've got a couple quarts of oil. I put like 50 psi of air pressure in this tank. So this tank will actually, as soon as I turn that valve, it's going to pressurize the engine. So I just got a loop hose here. So, because remember, this fitting is oil out of the oil pump, and then it goes right back into the lifter galley. That galley there is the only thing that feeds the lifters. There's the galley in front that can share it, but this is the main guy. So this is normally the oil filter. Well, since we don't have the cylinder head and stuff on, I'm not going to go through and all and hook up the oil filter. So I just want to pre-lube this thing, and I want to see what goes on. So I'm going to go ahead and flip this valve. Ooh, I hear it gurgling out of here, so that's good. That means that check valve opened at 20 psi like it's supposed to. I'm holding good oil pressure. That means I don't have any massive leaks in the engine, so that's a good sign. So there's a hole, look at that, there's a hole on top of the fuel pump push rod. To help lube that. That's kind of cool. That's the smart thinking on Lincoln's part. I didn't know that was there, to be honest with you. But we're feeding her up. I put a dial indicator on this valve, so I zeroed it at the maximum lift. So what I'm going to do is, I figured I'd turn it over, and with the lifter pumped up, I should have more lift than what I had with a pump down lifter. So I'll do that. But like I say, it looks pretty good so far. Yeah, the flathead V8s, they don't lube to my knowledge. That's pretty interesting. Because that was always a common problem. The freaking push rod would wear and won't stroke the fuel pump. But oh, we got a spitter. My tank is out of oil, so that means we're pumped through. So let's see what she does. All right, here we go. We're gonna test fire the 48 Lincoln V12. Yes, I'm running on 12 volts. That's not good, but hey, it's a lot easier than trying to dick with a 6-volt battery. But anyway, let's see what we got here.